All right, so now we're going to do the third example in section 10.7, which is talking about the probabilities of dependent events. Okay, so we're learning that the events they don't affect one another, but now you're going to see that the dependent events do. Okay, so for here, our probabilities are going to change a little bit. So in this case here, it says if A and B are dependent events, then this is your probability, okay? It's the probability of A still times the probability of B, but notice B says after A. All right, so let's take a look at example. It says here a class has 18 boys and 12 girls. 2 students are chosen at random. So I wish I could actually do this with you guys in school. So it says here, what is the probability that a student chosen will be a boy and a girl? All right, so I need 2 students from the class, okay? So here we've got a class, 18 boys, 12 girls. We've got 30 students all together in our class. So what's the probability that the students chosen, one will be a boy, one will be a girl? All right, so the first event, okay, says boy, then girl. So in order to choose a boy, there are 18 out of the total, which is 30. Okay, so we see that here. That's probably 18 out of 30. We can reduce that, simplify that. We'll do that in a second. But now, so I chose one student. Now I'm choosing a second one. Now, as soon as I chose that student now does not go back. They can't be picked again. So since they can't be picked again, now from the class that I have, there are no longer 30 students. Now, since one of them got chosen, now there are only 29 students I can choose from. And this probability that it says here, selecting that it's a girl, that would be 12. So 12 out of the 29 now. So this is an example of a dependent event. And just like we did with the independent events, you're just going to multiply these fractions together. Okay? And you can see that from the work. They didn't reduce first. They got 216 over 870, and then they just simplified with your percentage. So you can do that in that case, okay? All right, now same example, okay, but this one says here, what's the probability of selecting 2 boys? So here, selecting a boy would still be 18 out of the 30, but let's say, what's the probability that we get 2 boys instead of the first example where we get a boy and then a girl? So now once we select that boy, now there's only 29 to choose from. But here, if I took a boy from the 18, now there would only be 17 left. So that's the probability of a second boy having chosen the first one. So this is an example of the dependent event. Okay, so let's take a look at some examples. So here in example 5, it says a bag contains 3 red, 5 green, and 2 blue. What's the probability of selecting a blue? Now notice it says here, setting it aside. So unlike our independent events, I'm not replacing it. So I took it out and now it's off to the side, okay? So first we have 3 red, 5 green, so that's 8 plus 2 blue. I've got 10 marbles in the bag altogether. So selecting a blue would be the 2 out of 10, or that simplifies to 1/5, okay? Now notice it says here, now selecting a red after the blue has been selected. So we're setting aside this marble, we're not replacing it. So here, selecting your red would be the 3 out of, now we didn't place that blue marble back. So now in my bag, I only have 9 marbles to choose from. And I'm going to simplify because I always like working with the smaller numbers, but you're using calculator, it doesn't matter. So now we're going to take the 2 together. We're going to take the 1/5 times the 1/3, and the probability of selecting a blue and then selecting a red would be a 1 out of 15 chance, okay? And it would be the same thing if you took 2/10 and multiplied it by 3 9s. All right, take a look at number 6. Number 6 says here, 26 cards with all the letters of the alphabet are placed in a box. What's the probability of selecting a vowel, setting it aside, and then selecting another vowel? All right, so we have 26 cards in the box, okay? So we know that out of the total is 26. So selecting a vowel, which they told us is A, E, I, O, U, so that's 1, 2, 3, 4, 5 vowels out of the 26 total letters. So that would be the probability of selecting a vowel. But then it says selecting a vowel, setting it aside. So now that one vowel gets put to the side. I chose one of those. And now I'm selecting another vowel. So when I put my hand back in that box, there are only 4 vowels to choose from out of a total now, which are 25. Multiply them together. So 5 times 4 gives 20 out of 26 times 25. That's 650. And then we can simplify that. But I'm just going to write it as a percent. That's about 3%. Take a look at 7 and 8. And these ones are kind of just like 5 and 6. So instead of me kind of going through them, I'll just give you the answers. But now what I want you to do is go back to your textbook for homework. On page 755, let's finish 12, 13, and 14.